This week it's the intermediate data manipulation in R. Yeah, so really just working off the fundamentals from the intro workshop. So it's nothing really new. Just I'm going to be introducing a few more dplyr verbs. So we went through like the arrange, the select, and like a couple of those in the intro one. So I'm going to be showing you a lot more, some advanced ones, and then mainly just getting into like chaining the various verbs together with that pipe operator and answering some interesting questions. So let's go ahead. There's no data set this time. That's because I'm just going to be introducing the there's a data set within the R, like it's an R package that we're going to be using, so you don't have to really download anything. But I'm going to share the link here for you to hold on, I need to pull up the chat. Chat. You can just go to this link and it should have you log in to join the space. I'm sure some of you already are on the space, but if not, just go ahead and try that. And then let me just send the link again in case that one didn't work. Try the second link. The second link should take you to the actual notebook itself. And so remember, once you guys click that link, you want to log in with your Google, assuming you've made an account, right? And then it'll sign you in here, and it should show you here intermediate data manipulation in R. And go ahead and click start because I've made it. Oh, okay. Yeah. So there's a hackathon on Friday. It's for the AI2S. It's an international hackathon with Italy. So you can go in the general chat of the Slack group chat, and you'll see that there's a sign up for it, and the sign up is tonight. So yeah, there's the link. So go ahead and start the intermediate data manipulation in R thing here. So I made it an assignment. So you can go ahead and just wait till that loads. Yeah. Sorry. Yeah, so it's gonna load here. Let me know when you guys are ready to. Oh yeah, and once this loads up, right, this is the R Markdown file here. So you're just gonna click on this, and it will show that here on the left side. And again, there's no data set because we're gonna use an R package, which contains the data set for today. And once you guys get to this screen, I just want to show you guys, I always like to do this. I like to change my global options. So I go to tools, global options, and then I like to change the pane layout. So I like to have my console in the top right and the environment in the bottom left here. So go ahead and apply that. You can follow along like I did. So then I have this here, and then yeah, so just give me a thumbs up if you guys are ready to go, or in the chat if you guys are ready and are at this this screen. You're good? Okay, good, Jacob. Are the rest of you guys good? Andrew, John, Philip? All right, good. Cool. Yeah, so we're gonna go ahead and we're gonna install two packages. So we're gonna install tidyverse, which will contain the package dplyr, which we're gonna use, and this package called NYC Flights 13, which is the data set. So first let's install tidyverse. So install.packages, and then in a string put tidyverse. And remember, this is just gonna load in that tidyverse package, and that stop sign shows that there's a process going on. So just give it a moment for it to install here. And so if you remember, the tidyverse encompasses all the data science packages. So for like visualization, for data manipulation. So while that's, just give that a moment. Okay, so now that it's done, we're going to install a second package, which is the NYC Flights 13. So install.packages NYC Flights 13. So that's going to be the data set that we're going to use. It's just a bunch of flights during the year 2013 flying in and out of like LaGuardia and JFK and Newark. So we're going to be using that. So it's going to take a few moments. And then if you remember, after we actually install it in there, we need to load it physically into the environment. And the way we do that is with the library function. So library and then specify the package name, but not as a string. So we want to get the dplyr package and then the NYC Flights 13. So if we run that, that's going to load in the two libraries. So dplyr and NYC Flights 13. So now we want to physically load in the data set, and the data set itself is going to be different since this is a built-in package into R. We don't need to do read R or read CSV like before. So the data set itself is called flights. So the way we do that is we're going to just run data and then specify flights as a string. So that just loads in that flights data set. So we're gonna, that's the name of it. So that's how you would load it in here if it's a built-in package in R. So now let's glimpse the flights data. So just kind of observe the first few observations here. So okay, so you can see here, this shows us all the various columns in our data and a couple of the first few values for each. We can see that there's integers, doubles, characters, things like that. And since this is a built-in package, we can also, just check the documentation to see what more information on this data set. You can only do this if the data set is built into R. So to do that is you in the console to the right, just do question mark and then do flights. And so this here pulls up some information on our flights data. So here you can see on-time data for all flights that departed NYC for JFK, LaGuardia, Newark in 2013. These are the various columns. So we can see that, the date of departure, actual departure time, right? The carrier, the flight number, the tail number, the origin and destination, the amount of time spent in air in minutes, the distance in miles, and all the various things, right? So I'm just going to have this up here, so in case we need to refer to it. So let's get the first few rows or the head of the data. So do head and then do flights. Right. So you can see here, it's just the first few observations, and we can flip through this and look through the columns if we wanted to, right? So that's that. Now we're going to get into some advanced subsetting. So before the intro to data manipulation, you may have noticed that, we learned the select dplyr verb, right? So what you would do is you'd say select and then specify the various columns in your data, right? But it could get a bit tedious sometimes if your column names all end or start with the same character sequence, right? So let's say we wanted to select the department time, the scheduled department time, the arrival time, the scheduled arrival time, the air time, right? All of those end in time, and we could specify every single one of those column names in the select function, but that would be too much. It would get pretty tedious, especially if we had a bigger data set. So dplyr allows us to, gives us these helper functions that we can specify in our select function here. And that's ends with and starts with. And you may already know what that's going to do. If it's a column name which ends with a certain character sequence and they all share it, then you pass in your data, right? So I'm going to be using the pipe operator throughout this whole entire this tutorial, but you can also specify it as a argument itself. But here you pass in your data with the pipe operator, select, and then do ends with that whatever character sequence, and it returns those selected columns which end with that sequence. Similarly, if it does starts with, right? If we want to do, we see here there's our time or arrival time, ARR, and arrival delay. Let's say we wanted to just get everything which starts with that, right? The ARR. So we can just do select starts with, and then that character sequence. And then if we wanted to get multiple column names which start with or end with a certain character sequence, right? We can just pass in, instead of just a single character string, a vector or a kind of like a list of those individual sequences. So a vector in R is done with, you write C and those two parentheses. So it's kind of like a list, but it's just a data type in R. It's called a vector. Same thing as an array though. So let's return all the column names that start with the DEP, right? So let's go ahead and do that. So let's do flights and select, and let's do starts with DEP, right? DEP, right? And if we run this, we will get only those two columns. So again, we could have also done flights, select, departure time, and departure delay. That would have also done the same thing, but this is just a little bit more elegant, right? Let's return all, I missed this one here. Return all column names which end with time, right? So let's do flights, and then let's do select ends with time. So if we run that here, we're going to get all of our rows and then the various, departure times and all the columns that share that specific character sequence. So here, let's do more than one character sequence. Let's do for select all columns that end with time and delay. So here, since it's more than one, we're going to specify that vector. So we're going to do flights, select, and then let's do ends with. And then since it's more than one, we're going to do a vector of strings. So it's going to be time and delay. Be careful with your parentheses here because that can sometimes throw an error if you don't specify those correctly. So here you can see that we got all of the various columns which end with time or end in delay, right? And we could have also specified these individually as well. And then let's do all the columns that start with DEP and ARR. So let's do flights, select, starts with, then since it's more than one, specify vector. And what did I say? I said DEP and R. Okay, DEP and R. And then again, if you guys remember, if you wanted to just run this single line, you just highlight it here, and then you go up to the top and then just do run selected lines, and then it just gives you that one. So here you can see it's, we got all of the columns which started with a DEP or ARR. So those are two ways that you can select various columns from your data, especially if you have more than one and they share a specific character string. So we're going to get into now filtering our data frames. So before, in the previous tutorial, we were selecting specific columns, but we were only returning all of the rows, right? We never filtered for certain values in our data set. And this filter verb in dplyr is really helpful, and it's something which is used a lot, especially when you want to explore and filter your data set for specific values. So here I'm going to, so just to kind of show you guys here, we're going to do the first one where we filter for the origin name. So the origin here, that contains the various the airport that it left from. So we're going to filter for the flights originating from JFK. So let's do flights, and then we're going to do filter, and we're going to do origin. And to specify your condition, so the way you do this, right, is you pass in your data, but you say the column that you're filtering for, and then equals the double equal sign, the specific value. So that's your condition that you're filtering for. So our condition is the origin column in which the values equal the string JFK, right? So if we run this, oh, I spelled that wrong. So if we run this now, we can see that our origin column here contains only JFK because that's what we filtered for. And you can also specify more than one condition. And that's why I have this ... here, because if you want to specify more than one condition, all you do is just separate it with commas. Simple as that. So let's filter for flights with the carrier of American Airlines AA and destination heading to Miami. So we're going to be looking at the DEST column and the carrier. So let's do flights, and then filter for carrier for AA and the destination heading to Miami. And when we run that, we will get that our carrier is only American Airlines, and our destination is only Miami, right? Now let's do one more. Let's filter originating from LaGuardia and heading to Boston. So let's do flights, filter, let's do carrier, or no, origin is LGA, and the destination is Boston, so BOS. And if you're wondering how I'm getting these values, it's just the values from the data set itself. So BOS refers to Boston in the data set. So, right, you can see here that we got all flights originating from LaGuardia heading to Boston, right? Simple as that. So that's the filter verb. And we can also filter for multiple values. So just now we were only filtering for one carrier or one value from the origin or something like that. But we can very well filter for multiple values from a single column, right? And to do that, we would do the same thing, run the filter command, but what we do is we would pass in a vector specifying the values that we want to filter for, and we say that the column is in that vector, and that's our condition. So if you remember, if you came to the pandas one last week, I showed a similar one where it was the is_in function, right? You take the column and say whether it's in the values vector or not, and if it is, then we filter for that, right? So that's what we do here. And similarly, if we wanted to return all values that were not in that condition, right? So let's say we wanted values that were not in this column and that didn't contain this value, right? So then what we would do is just wrap that condition with a exclamation point operator. That's the not operator in R. So let's filter for the destinations. Flights heading to destinations Houston, CMH, and Atlanta. So let's do, it's called flights, right? Flights, and then filter. And the column is called dest, so dest, and then in. So that's saying that we want to look for values in the destination column that are in the vector that we were going to specify, which is Houston, CMH, and ATL Atlanta. And if we run this now, we can see here that we have filtered for those specific values, Atlanta and Columbus and Houston, right? And now let's do the opposite. Let's filter for those that are not heading to that, right? So we know that this is going to return everything that it is not in Houston, Atlanta, or Columbus. So let's do filter, and then let's do the exclamation point, and then in parentheses do dest in C Houston, CMH, and Atlanta, right? And I'm just going to run this individual line here. And you can see that it will return everything that's not in, you can't see Houston, CMH, or Atlanta, right? And now let's do a couple others. Let's filter for flights originating from JFK and LaGuardia. Flights, filter, and let's do origin in JFK and LaGuardia. Again, same thing, return that data frame with the filtered values. And then let's do not. Let's do flights, filter, and then not in those values. So JFK and LaGuardia. So now when you run that, you see that we get way more values in this than this because we've included everything but these two. So that's how we would use the filter to filter for multiple values. But now
I have a quick question. You might answer here. It's basically, can you do a filter that's not in, like, let's say, not going to Atlanta, but they are going to Houston? Can you do like 2 and 1 for the nots? And
yeah, so like kind of like it's not going to Houston and it's going to another one. Is that what you're saying?
or it's going to Columbus.
Yeah. So I'm actually about to get into that.
Sorry about that.
Yeah, no problem. It was perfect timing because now I'm going to talk about conditional filtering. So kind of what we just talked about here, we are going to, if we wanted to filter for more than one condition here, and we can do this with the ampersand operator if we wanted to say and. So here, if we wanted to filter for two conditions, right, we can do data and then filter for one condition and the other condition, right? And that's what you would pass in if you wanted two conditions to be met. Let's say you wanted to filter for one or the other. In R, the way you specify the OR operator is this vertical bar, right? So we would say data, and then these conditions would be different, obviously, and then you would say whether it meets this or the other. So you can specify this way, or you can have them wrapped in parentheses. As long as you have this OR operator and operator, R will be able to recognize that. And then again, you can also filter for values as well, right? So up here, I was saying that like these should be strings, but obviously if you're checking for numeric values, you can make these integers and they don't have to be strings. So here, if you're filtering for a column being less than a certain value, then you could say, okay, less than an integer, less than or equal to, same with greater or greater than equal to. And then you can obviously take those conditions, right? You could say something is greater than a value or it's less than a value. Similarly, you can use and. But the thing I'll say about that is, while that is, that works using the, to specify an interval for something that's greater or less than, R has a helpful method called the between helper function. So, something like this here, if we did filter for a column being greater than a certain value and less than a certain value, right, we would get that interval of values that meet these conditions. But one of the helper functions that's given to us in filter is called between. And what between does is that it takes a column, most likely a numeric column, and then you specify your value 1 and value 2, which are your lower and upper bounds. So this right here is similar to this. that, we want everything that's from value 1 to value 2 in this numeric column. So let's go ahead and practice this stuff. Let's filter for flights that flew to Houston or CMH. So let's do flights and then filter, and then let's do the destination being Houston or the vertical bars CMH, right? So if you run that here, we can see that it meets either one of these conditions here, right? And then let's filter for those that flew to CMH and their origin was from JFK. So we want both conditions to be met. So we're going to do filter, and we're going to do the destination is CMH, and the origin was JFK. So you can see how, we've taken this big data set that we've had and we've shrunk it down to these 742 observations. And that's really the power of this filter function and these verbs, because we can answer interesting questions that we want. Let's filter for flights that were between January to April. So here, this looks like a prime candidate to use that between function. So let's go flights, and then let's filter for, let's do between, right? And the first argument is the column that we want to look for. So that's going to be, I believe it's just month. And then the lower value will be January. So that's 1, and April, which is 4. So if we run that, we get everything from January to April here. And you can also click through these rows if you wanted to explore that. So that's that. And then let's filter for flights that flew to LAX and flew after March 3rd. So another and operator here. So we're going to do flights, and we're going to do filter between, or no, not between, just regular. So that flew to LAX. So the destination was LAX, and after March 3rd, flew after March 3rd. So month being greater than 3. So now you can see here that we get only months after March that flew to LAX, right? And so that's the different ways we can use that filter function and conditionally filter. So you can make this complicated as well. You can make this as complex as you want. You can specify your various different conditions, use those and operators, those or operators to your liking, right? The only thing is just make sure the parentheses are always there. So the thing about dplyr is that we want to combine these various verbs together, right? So we've just been using filter, we've just been using select, by itself, but the power of dplyr is combining these various verbs together to answer questions. So we're just gonna do some practice here. We're going to filter, select, and arrange our data frame here. So we're gonna filter by flights that are on December 31st. So you know that we want to filter for the month that's equal to 12 and the day that's the 31st day, and then headed as the destination to Columbus, right? So let's do that. Let's flights, and then let's filter for the month that's equal to 12, and then the day that's equal to 31st, right? 31, and destination being CMH. Right? So we've just filtered it. Now let's select the various columns that we want to work with. So let's say we want to select the month column, the day, the destination, the carrier, the origin, the tail number, the airtime, and the time hour. So as you can see, that was kind of getting on a new line. So if we wanted to put this on a new line, R still recognizes this pipe operators being plugged in here, so we can just specify a new line. Similarly, let's now arrange it by airtime in descending order. So if you guys remember from the first intro to data manipulation, there's the arrange function. So we're going to pipe that into the arrange function, right? And to say that it's in descending order, we do DESC and wrap that around airtime. So we have filtered for the given conditions that were December 31st, headed to Columbus, Ohio. We've selected our subset of data here, DEST. We've selected our data that we've wanted, and we've arranged it by the variable that we want to arrange by. So let's run that. And you can see here that we have our subset, and we can see that it's descended in descending order by airtime, right? So we can see the various flights, and we've shrunk it down. And again, I've been just doing this normally, but if you wanted to save this to another object, you can do that as well. Just save it to another variable, call it like flight subset. We'll be doing that a little bit later, so you don't always have to work with the whole data set as it is. Let's do one more. Let's filter for the flights that flew to Columbus as the destination. And then that flew between the months of June to December, and then select the month, day, year, and arrange by descending order the departure delays. So let's first filter. So let's do flights, and then filter for the flights that flew to Columbus, Ohio. So that is the destination being CMH. And then between, right, for the month column, and that were between June to December, so 6 to 12, right? And then we want to select the month, the day, the year, the destination, the carrier, the origin, and the departure delay. And then we want to arrange in descending order by departure delay. So now let's run this. And so now you see that we have gotten our conditions met and this code runs, right? So we've shrunk it down to another subset. So that's really the power of this pipe operator and these various verbs, that you can chain verbs together to answer questions that you want relatively quick, right? So now let's go ahead and introduce a new dplyr verb. So we've learned the various helper functions, we've learned filter. Now I'm going to get into group bys. So what group bys are is, let's say you wanted to do some summary statistics. We talked about summarize from the first intro to data manipulation. Well, what group by does is it allows you to make grouped summary statistics by specific columns. So let's say we wanted to summarize, do summary statistics like the mean, maximum, for these 3 columns, but we want to group it. So what we could do is we could say, okay, I want my data, and then I want to group by these specific columns and summarize it with the various column metrics. So like the mean of column 1, the mean of column 2, things like that, right? And let's say, after we want to do some more computations after that, but we don't want our data grouped, right? We can simply just, say we want to group by the column names, summarize it, but then say ungrouped, say, okay, I want to ungroup it, and I want to now, let's say, filter, do other stuff. And then, if we want to work with our data and we realize that there's missing values, which is oftentimes the case when we do grouped summary statistics, well, then what we do is that we specify an argument within this mean function. So let's say we're summarizing, and our column 1, which is average, is going to be the mean of column 1. So then we just do mean of column 1 and then say na.rm equals true, and that means remove the missing values. Now, we don't always want to just remove the missing values. We want to handle them in a certain way, and that's going to be coming up in an upcoming workshop. So for now, just specify na.rm true, and that will remove the missing values, and we will get our group summary statistics. So let's practice here. Let's do flights, and let's group by the destination. So let's group by the destination, and then let's summarize. And so let's do the mean arrival delay. So I'm just going to call it average delay, right? Average R delay, right? And this, if you remember from the summarize right? This is the column name that it's going to be in our summary table. So average, and that's going to be the average of the arrival delay column. And then we're going to do another one, which is going to be the average distance. So let's do average distance will be the name of it, and that will be the mean of distance. And then let's do the average airtime. So let's call it average airtime. And let's do the mean of our original column, which is called airtime. Right. So now when we run this, we will get our grouped summary statistics. But now you see here that we have these NAs, right? We have these missing values in our group summary statistics. So to handle this for now, what we will do is we'll specify that argument na.rm. So na.rm is equal to true. And we put this in our mean function. So if I want to make this a bit more readable here, I could just put it on a new line like this so it's easier to see. You can see we've named these 3 columns, gotten our summary statistics grouped, and now when we run this, for this one here, our missing values have been handled, but it seems like we still have to handle these, and we can do that. So now let's do it for the next one. Let's group by the tail number and origin, summarize to compute the average departure delay, the maximum airtime, and minimum distance, and remove the missing values. So here I just realized I didn't put the rm equals true for all of them. I just did it for the one. So make sure you do that here. So you want to specify that argument for all of them. So now we can see all of them are removed. So let's do that here. Let's do the flights, and then let's group by the tail number and the origin, and then let's summarize here. Let's do the average departure delay. That's the mean of the departure delay, right? And then we want to remove the missing values here. And then now we want to do the maximum airtime. So I'll just call that max airtime, and then airtime, and then remove those missing values. And then minimum distance. So minimum distance in the min function, and let's do distance na.rm equals true. So now when we run this, let's see what happened. Tail number. Oh, it's just called tail num. My bad. So it's called tail num, not tail number. That's the column name. So now we see here that we've gotten our grouped summary statistics, and it has removed our missing values. So this is just an error function that just says that we've removed the missing values, but we should still look into them. So this is just kind of like a good fix for now. So that's group bys. It's usually used with your group summary statistics, so you can explore those and do some more analysis. So that's the group by. And another verb that we're going to learn about here is called mutate. And what mutate does is that it takes the original columns you have, right, and it creates a new column based on that. Or in other words, it essentially creates a new column as a function of your old ones. And so what that means is, let's say you want to create a column which is the difference of 2 existing columns in your data frame. So what you do is you pass in your data, you call mutate, and then you, let's say you name that new column difference column, and you say, okay, I want it to be the difference of, column 1 and column 2, right? It would create a new column in your data frame called difference column with this operation done across all the rows. Let's say you wanted to do for the sum, right? Similarly, column 1 plus column 2. So generally, mutate is used when you want to do some numeric operations amongst different columns, and you want a new column based on that. It's used a lot with numerical data. So you can also specify more than one operation in a mutate. So let's say I wanted to do all of these in one line. I would just show your difference column, the various operation, and separate it with commas here like I have done, right? So Now let's just practice this, right? Let's create a new column which represents the difference between the departure delay and our arrival delay and call it gain delay. So let's do flights and let's mutate. And we're going to call it gain delay. So let's do gain delay is equal to the original columns, which are going to be the difference between our departure delay column and our arrival delay column. So let's do that. And then, so that difference, and we've now used that mutate column or mutate verb to now, if you look in our data frame, we have our original departure delay and arrival delay here. But now if we keep going, we can see that we've just created a new column called gain delay, right? Simple as that. So let's do this again. Let's create two new columns this time. Let's create the difference between the departure time and arrival time. This time we'll call it gain time. And then the speed. So that's going to be distance divided by our air time. But since we want it in seconds, we're going to multiply it by 60 because our air time is originally in minutes. So let's do that here. So let's do flights and let's mutate. And so we're going to create the first one, which is called the gain time. And that's the difference between our original two columns called departure time and arrival time. And then we're going to specify a comma and say that we want to now have a new column that we're going to mutate or create here. So we're going to be creating two columns, the second one being speed. And that's going to be our distance divided by, let me just put this in parentheses just so the operation. So distance divided by our air time. And then since we want it in seconds, multiply it by 60, right? And so now when we run that, we have in one line of code, we've just created two new columns here to create gain time and speed. But if you notice, we don't have this gain delay here, and that's because I didn't save this to a new data frame object, right? So it didn't save my changes. But if you want to save your changes, you can save it to a data frame object, so you have all three of these columns, right? So like I said, we can work with subsets and create objects to store that. So let's create a subset of the data called flight subset. So let's do flight subset, right? And that's going to be, so to set a variable, you do that symbol, and it's going to be it's going to include anything that ends with delay. So it's going to include we're going to select all columns that end with delay. So ends with delay, right? And then we want the distance. So put a comma, and then we want the airtime, right? So we have selected the various data we want, everything that ends with delay, the distance, and the airtime, right? So now we've created this flight subset data frame. So if we run this here and we do flight subset, you see it has been stored here. We have our subset data. So now with this flight subset data, let's create two new columns. Let's do mutate. So we're going to do flight subset, and we're going to do mutate, and we're going to do the like above, the same thing. I'm just going to be showing you another thing. We're going to be doing gain delay, just like before, the difference between departure delay and the arrival delay. So gain delay is departure delay and arrival delay, right? That's the difference. And then comma to specify a new column, and we're going to do the airtime hours. So that's going to be the airtime expressed as hours. So we're going to divide it by 60 because it's already in minutes right now. So I'm just going to call it airtime hours. And since we want it in hours and we want to get it from minutes to hours, we're going to do airtime divided by 60. Right, comma to specify one more column. And the thing about mutate is that we have specified two new columns, but if we wanted to use another column, if we want to make a new column and use these, we can. So I'm going to call this gain delay hours, and I'm going to use the gain delay divided by airtime hours, right? Because let's say I want to calculate something like that, So here I have used these two columns that I've mutated in my new mutated column. And that's because with this pipe operator, it tells R that we have created those columns in that one line of code. So now you can see here that I've created 3 columns here. I've created gain delay, airtime hours, and gain delay hours, right, in one line of code. And I got to use these mutated columns in that mutate function, right? So that's mutate. And that mutate filter, those are really useful for when you want to filter your data set like we did and save it to an object and create new columns. So let's say we want to, we've arranged our data set and we want to maybe, instead of just returning everything that we've arranged in descending order, we want to, maybe you want to check the top number of values. You want to check the top 5 that meet a certain criteria, the top 5 values, top 10, right? So this verb top n is used for that reason, right? So what you do here is you pass in your data, you say top n. That's the function, and we will say the number argument, which specifies, I want to return the top 5, right? You say that top number of observations you want to return, and then you say what column you want to return the top 5 of. So generally, this function you want to use after you've arranged beforehand, because if you have, let's say you've arranged in descending order, then top n is just naturally going to return those top 5. Right. So let's practice this here. Let's select everything that ends with delay in time, the destination, the origin, and the tail number. So let's do flights, and then select everything that ends with, and then since it's 2, we're going to specify a vector, right? So delay and time. Right, watch your parentheses here. So that's one thing that we want to select. So now we want to select the destination, the origin, and the tail number. Right. So we've done that. And now after we have selected, we want to now arrange by descending order of the departure delay. So let's do type operator arrange by descending order of departure delay. And then we want to pipe that into the top n function. So you want to return the top 5 departure delays. So let's do top n, and then let's do 5 for our number and by the departure delay column. So now when we run that, you can see here that we have returned the flights and the various destinations and the origin and the tail numbers for the top 5 departure delays, right? So we can investigate that and see which flights those were. And that's what top n does for us, right? So let's do this again. Let's select everything that starts with the departure and ARR, the destination, origin, tail number. And then same thing, arrange it in the descending order and return the top 10 this time. So let's do flights and select everything that starts with this time. And since we're doing 2 character sequences, it's going to be a vector. It starts with DEP and ARR. And then we are going to get the destination, the origin, the tail number, right? So closing parentheses. And now we are going to arrange it by descending order of the arrival delay here. And we're going to pipe that one more time. And we are going to now return the top 10 observations of that descending array arrival delay column. So let's do top n 10 and arrival delay, right? So now if we highlight this and run it, let's see what happened. Tail number, select tail number, starts with departure. What happened? Okay. Okay, there's probably some error here. Oh, I didn't close those parentheses. You see that? This parentheses here messed everything up. I didn't have a closing parenthesis, so it threw a syntax error. So that's the importance of checking your parentheses. So here now we've gotten our various columns, we've arranged it, and we've got the top 10 arrival delays. We've got the flights with the top 10 arrival delays here, and you can see, you can check it, it's in that order, in descending order, right? And we've got top 10. So that's top N. And so now in the last 10 minutes here, we're just going to do some pretty complex, well, not complex, it's just going to be a lot of just chaining these dplyr verbs together, right? Select, group by, arranging, filter. We're going to just kind of, use these verbs together to return various subsets of our data and just play around with them, because just doing this kinds of practice will only make you more competent with it. So let's do the first one. Let's select from the flights data set. So let's do flights, right? And this is why I emphasize using this pipe operator and not just doing it the hard way, because you can really, it makes the computations a lot easier. So we're going to select everything. So, if you guys remember, so the way, if you have a ton of columns, which are just kind of like in a row, so year, month, day, you can just say you want everything from year to day and do a colon between them. So that's what I'm going to do here. I'm going to do from everything from year to day. So year, colon, day. So that's from everything. I want to select columns from the year column to the day column and everything in between, right? So year to day, and then I want the distance, and then I want the airtime, and then I want the destination, and then I want anything that ends with delay. So anything that ends with delay, right? That is our subset of our data frame. And then now that's what we selected. Now let's group by our year, month, and day. So a year, month, day. Let's now arrange that data that we have, and now let's pipe that into the arrange column, and let's do arrange by descending order of the arrival delay, right? So now our data has been arranged, it's been grouped, and now let's filter. So let's do another pipe operator, and let's filter for the months between January to May, right? So the way we would do this is we do between, right? And we want to go get everything from the month column between January to May. So that's 1 to 5, right? And now let's run this. And we can see here that we have gotten our data, which indeed matches these descriptions, right? We've gotten the columns we want. We have it arranged in descending order of the arrival delay. As you can see here, it's in descending order. And we filtered for months between 1 to 5, right? You won't see anything else but from 1 to 5. So that's one way that we could put everything together. Now let's do one last one here. And this is going to be really long. So it's going to be multiple lines here. So let's first start slow. Let's do flights, and let's select the various columns we want. Let's select everything from year to day. So it's going to be quite similar here, year to day. Let's get the distance. Let's get the airtime. Let's get the destination and everything that starts with the DEP and ARR, and we're going to do a vector, right? Let's do DEP and ARR. And then, so we've selected, now we're going to group by, and we're going to group by our year, month, and day, right? So we've now selected and grouped, and now let's see, now we want to mutate. So let's now we're going to be creating a new column in our data frame. It's called airtime hours, like last time. So let's mutate. Let's call it airtime hours, right? And it's going to be the airtime divided by 60. And now let's do the next operation, which is going to be now filtering. So another pipe operator, and we're going to do filter So you can see how this data is being passed through the various functions line by line. So now filter is going to be all the airtime hours that are greater than or equal to 2. So we're going to use that mutated column and now filter that. So let's do airtime hours greater than or equal to 2. Right? Now let's do another pipe operator. So we have now filtered, and now we're going to use our summary statistics, and we're going to summarize. So let's do summarize. And we are going to summarize. We're going to do the mean airtime hours. So let's do mean air hours is going to be the name. Let's just mean of airtime hours, that column we've created from mutate. We're going to do the mean departure delay. So mean dep delay, mean departure delay, comma, the mean arrival delay. So let's name it mean ARR delay. Right, and let's do the departure time and arrival time as well. So mean departure time and arrival time average. And of course, you don't have to always do mean. I just did it for simplicity. Right. So we have summarized, we've filtered, we've mutated, we've grouped. And now this is where we want to now ungroup, right? So let's say I don't want to work with this grouped data frame, right? I want to now filter it even more. I want to arrange it and I want to do top end. So this is where you would use ungroup, where you want to compute the summary statistics, but then ungroup it, right? So ungroup, and that takes no arguments. And then you do another pipe filter here, pipe operator. And now we're going to arrange by the descending order of mean air hours. So that that summarized column, right? And you can see it popped up there because R realizes that we have created those columns and it's passing it through. And now let's do the final step, which is the top 5 observations from the mean air hours. So top N, 5, and mean air hours, right? That was a lot. And, obviously there's probably a simpler way to do this, but, I just want to show you how we could use these dplyr operators. And as you can see, we have transformed our data completely from the original flights data frame all the way to our summarized statistics and our top 5 flights with the average mean air hours. And you can see that it's in descending order, and we have done that, right? So yeah, that's today's workshop in intermediate data manipulation in R. I hope you guys learned a lot about some new dplyr verbs, and you can put this to the test and work with this in your own projects. So yeah, I'm glad you guys came out. If you guys be sure, if you're interested in doing that hackathon, sign up via that link that Enan sent, and you can practice some of this stuff. So yeah, if you have any questions, feel free to send me a message on Slack, and you'll see this on the Carmen course as well. So thank you guys.